People love the idea of time travel. They really love it. I think it's because it sounds like cheating. You mess something up, you rewind. You miss an opportunity, you go back. You get older, weaker, and more forgetful, and you say, I'll just hop into a time machine and straighten it all out. But now let's be careful here. Whenever someone says time travel, I always want to ask them a very simple question first, something embarrassingly simple. What do you mean by time? And that's usually where things start to fall apart. Because most people aren't talking about time. They're talking about memory, regret, stories, or wishful thinking. Physics is much more boring and much more interesting than that. The trouble is, time feels obvious. You feel it ticking. You feel yourself aging. You look at a clock and you think you understand it. But feeling something is not the same as understanding it. A thermometer doesn't feel temperature. It measures it. And physics is about measuring things carefully, not about how poetic they feel. So before we ask whether time travel is possible, we have to do something that makes people uncomfortable. We have to stop trusting our intuition. So, what time really is. In everyday life, time feels like a river. People love this picture. You're floating along, being carried from the past into the future, unable to stop the flow. It's a very nice image. It's also useless, because the moment you ask a simple question, how fast is the river flowing, you get nonsense. 1 second per second? That's not physics. That's just repeating the same word twice and hoping it means something. In physics, we don't ask, what does time feel like? We ask, how do we measure it? And the answer is almost disappointingly simple. Time is what we use to order events. That's it. When one thing happens before another, we say it happened earlier. When it happens after, we say later. Time is not a thing that flows or pushes or drags anything along. It doesn't do anything. It's not an actor in the play. It's the numbering system we use to keep track of the scenes. People get confused because they think time causes things. They say, time makes me old, or time ruined the milk. No. Bacteria ruined the milk. Chemical reactions changed your body. Time just tells us how fast those things happen. Time is a ruler, not a bulldozer. Now here's where things get interesting. You notice that time seems to have a direction. Eggs break, but they don't unbreak. Smoke spreads, but it doesn't crawl back into the cigarette. You remember yesterday, but not tomorrow. Why? This is not because time itself has a preferred direction. The laws of physics, most of them, work perfectly well forward and backward. The reason time feels one-directional has a name: entropy. Entropy is just a fancy word for messiness, or more precisely, the number of ways something can be arranged. There are very few ways for an egg to be whole, and billions of ways for it to be broken. So naturally, things move from fewer possibilities to more possibilities. We experience that increase in disorder as the passage of time. Your brain is not sensing time flowing, it's detecting change and increasing disorder. And that distinction is absolutely crucial when we start talking about time travel. Now let's get into the part everyone really wants to hear about: Einstein. People think relativity is mysterious, mystical, or impossibly complicated. It's not. What's difficult is letting go of bad assumptions. One of those assumptions is that time ticks the same for everyone, everywhere. It doesn't. And we know this not because Einstein was clever, though he was, but because experiments tell us so. Here's the idea. Imagine space and time as part of the same thing, a kind of four-dimensional map. You're always moving through this map, always, even when you're sitting still. If you're not moving through space, you're moving entirely through time. If you start moving through space, walking, driving, flying, you divert some of that motion away from time. The result? Your clock ticks more slowly. This isn't philosophy. It's not interpretation. It's measured. We've flown atomic clocks on airplanes and brought them back. They disagree with clocks that stayed on the ground. Satellites in orbit experience time differently than clocks on Earth. If we didn't correct for this, GPS systems would drift by kilometers every day. So time dilation is real. But now let's be very careful, because this is where people leap off the cliff. Time dilation does not mean you can hop into a machine and jump around history like a tourist. What it means is this: if you move fast enough or sit near a strong gravitational field, less time passes for you compared to someone else. You can travel into the future, slowly or quickly, by letting other people age faster than you. Astronauts do this already, just not enough to matter for birthdays. So yes, physics allows one very limited kind of time travel: forward. Backward is another story entirely. Now, let's tackle the dangerous question. Can you go backward? People love paradoxes. The grandfather paradox is everyone's favorite. You go back, you eliminate your grandfather, and poof, you never exist. So who did the eliminating? These paradoxes are entertaining, but they're a warning sign. When your theory produces contradictions, it usually means your assumptions are wrong. Physics is very strict about causality. Causes come before effects, not because we like it that way, but because that's how the equations behave. There are mathematical solutions, wormholes, closed time-like curves that seem to allow backward time travel. But seem is doing a lot of work there. These solutions require conditions we've never observed: negative energy densities, perfectly stable exotic matter, and other things that might exist only on paper. Now here's an important rule I've learned the hard way. If your theory allows anything you want, it probably predicts nothing useful. Physics isn't about what's imaginable, it's about what's testable. So far, nothing in nature suggests that traveling into the past is physically possible. Not forbidden by logic, perhaps, but unsupported by evidence. And that's where we stop. Not because it's boring, but because honesty matters. Now let's step away from equations and be human for a moment. Why do people care so much about time travel? It's not because they love physics. It's because they hate the present. People want to fix mistakes. They want to relive good moments. They want to escape aging and death. Time travel stories are not about time. They're about control. But the universe is not built for our emotional convenience. You are a process, not a passenger. You are not riding through time. You are part of what's happening. The present feels fragile because it is, and that makes it precious. Physics doesn't offer comfort. It offers clarity. And clarity, strangely enough, can be more satisfying than fantasy. Absolutely. Below is a direct continuation of the script, maintaining first-person Feynman voice, curiosity, skepticism, and grounded physics. I'll add new parts, expand ideas, and keep the tone exploratory rather than conclusive. Now here's something that really causes trouble. Even for people who think they've made peace with relativity, we keep talking about the past and the future, but what about now? Everyone feels that now is special. You feel like there's a bright spotlight on the present moment, sweeping forward, illuminating reality frame by frame. Yesterday is dim, tomorrow is foggy, but now feels real. The problem is, physics doesn't know what you're talking about. There is no equation anywhere in physics that contains the word now, and that's not an oversight. In relativity, what counts as now depends on how you're moving. Two observers, moving relative to each other, will disagree, perfectly legitimately, about which distant events are happening at the same time. This isn't a flaw. It's a feature. Imagine slicing a loaf of bread. If you cut straight down, you get one slice. If you tilt the knife, you get a different slice. Neither slice is more correct. It's just a different way of cutting. The universe is like that loaf. Time is one of the dimensions of the bread, and your now is just the slice you happen to be cutting through it. So when someone asks, what's happening right now on a planet a million light years away? The honest answer is, it depends on how you're moving. That's deeply uncomfortable. We want a universal clock. We want a cosmic referee shouting now for the whole universe at once. But there is no referee. And once you accept that, the idea of hopping around in time starts to look misplaced. People often say, okay, Feynman, maybe we can't do it now, but surely a sufficiently advanced civilization could build a time machine. That's a dangerous phrase, sufficiently advanced. It lets you hide ignorance behind optimism. Let's be concrete. Every serious proposal for backward time travel requires something exotic. Not just hard to build, exotic. Negative energy, perfectly stable wormholes. Matter with properties we've never observed anywhere in the universe. And there's a pattern here. Every time we push the equations hard enough to allow time loops, something breaks. Either the system becomes unstable, or quantum effects explode, or causality starts contradicting itself. Nature seems to have a very strong immune system. Whenever we try to cheat cause and effect, the mathematics pushes back. That doesn't mean time travel is logically impossible. It means the universe appears to be engineered, if that's the right word, to prevent it. And I've learned to take hints seriously. Physics is full of things that could exist mathematically but don't show up in reality. Unicorns fit nicely into biology textbooks too, if you don't insist on fossils. Another confusion people have is with memory. They say, if the past still exists somewhere, why can't we access it? Because memory is not retrieval, it's reconstruction. Your brain does not store the past like a film reel. Every time you remember something, you rebuild it. That's why memories change. That's why witnesses disagree. That's why nostalgia lies. You are not peeking backward in time when you remember childhood. You are running a simulation in the present. Physics does not allow information to flow backward freely. Entropy sees to that. Information gets scattered, smeared out, tangled with everything else. Once it's gone, it's gone. Time travel fantasies often confuse records with events. A photograph is not the past. Fossils are not the past. Light from distant galaxies is not the past. They're physical traces carried forward. The universe keeps receipts, but it doesn't keep backups. Now, inevitably, someone asks, if the future already exists in this block universe idea, does that mean I don't have free will? That's a terrible question. Not because it's stupid, but because it mixes categories. Physics describes patterns. It doesn't issue moral licenses. Whether the universe is deterministic or probabilistic, you are still the mechanism by which decisions happen. Your choices are part of the causal structure, not outside it. Asking whether you're really free is like asking whether a hurricane is choosing to turn left. It's the wrong level of description. And physics doesn't fix philosophical anxiety. It just tells you what's consistent. Here's something much more personal and much more revealing. People say time speeds up as they get older. Physics doesn't agree. Your clocks don't change. Atomic transitions don't get lazy. The universe hasn't touched the gas pedal. Your brain has. When you're young, everything is new. New patterns, new information, new memories. Your brain is busy recording. When you're older, more of life is repetition. So time hasn't sped up. You've stopped noticing it. That alone should make you suspicious of intuition. Suppose, just suppose, you could travel to the past. What exactly would you be traveling to? A place? A state of the universe? A configuration of fields? The universe is not a movie stored somewhere waiting to be replayed. It's a continuously evolving system with astronomical complexity. To recreate a past moment exactly, you'd need to reconstruct the position and momentum of every particle, not just locally, but everywhere. Miss one atom by a hair, and you're in a different universe. So when people talk casually about going back, they're imagining a simplified cartoon of reality. Physics doesn't run on cartoons. There is one asymmetry in time that matters deeply. Not time travel, but irreversibility. You can burn a book. You cannot unburn it. You can mix cream into coffee. You cannot unmix it. This asymmetry is not about time moving, it's about information dispersing. And that, more than anything, is what makes the universe feel alive. If everything were reversible, nothing would matter. No memory, no history, no learning. A universe where you could freely rewind would be a universe where nothing sticks. And that would be far stranger than one where time only goes forward. People often want physics to tell them something reassuring, that death isn't final, that mistakes can be undone. That time will give them another chance. Physics is not in the reassurance business. It is in the truth business. And the truth, so far, is that the universe is generous with possibilities but strict with consequences. You get one pass through most moments. That's not tragic. That's what makes them valuable. The deepest mistake we make about time travel is this. We think time is something we move through, but we don't move through time. We are processes extended in time. A flame does not travel through burning, it is burning. A melody does not travel through music, it is the sequence. You are not a thing riding a conveyor belt. You are the conveyor belt in motion. Once you see that, the urge to escape time starts to fade. People trust clocks far too much. They think a clock is time. Wind it up, watch the hands go around, and there you go. You've captured the universe in a brass circle. But a clock is just a very obedient physical system. It does one thing over and over again, and we count how many times it does it. A pendulum swings. A quartz crystal vibrates. A cesium atom flips its state. That's all a clock ever does. If you took the universe and froze everything, no atoms vibrating, no light moving, no fields changing, your clocks would all stop. And not because they're broken, but because there would be nothing left to measure. Time doesn't sit behind reality, supervising it. Time is stitched into the behavior of things. This matters for time travel, because many people imagine time as a track you could step off of, walk backward along, and re-enter. But there is no track. There are only processes. If you really want to understand why time travel is such a difficult idea, you have to pay attention to light. Light is the fastest thing we know. Nothing outruns it. Not because we're unlucky, but because the universe is built that way. And here's the crucial part. Light doesn't experience time. From the photon's point of view, if such a phrase even makes sense, it is emitted and absorbed in the same instant. No aging, no waiting, no journey. That's not poetry. That's what the mathematics says. Now think about what that means. Everything you see is already old. Light from the sun is 8 minutes late. Light from distant galaxies is millions or billions of years late. You are always looking into the past. Yet even with that delay, you never see the future. Why? Because information doesn't propagate faster than light, and causality rides on information. Any scheme that allows backward time travel would have to let information outrun light or loop around it. And every time we try to allow that, physics locks the door. There's another trap smart people fall into. They say, the equations don't forbid it. That sounds impressive. It's also misleading. Equations allow many things that never happen. They allow frictionless surfaces, perfectly rigid rods, infinitely thin wires, useful ideas, but not real. The universe chooses solutions, not all of them. Time travel solutions are often like balancing a pencil perfectly on its tip, mathematically allowed, physically absurd. One breath of quantum noise, and the whole thing collapses. Nature seems to prefer stability, not clever loopholes. Now, people often try one last trick. They say, but quantum mechanics. Quantum mechanics is weird. I'll give you that. It defies intuition. It laughs at common sense. But it does not give you a free ticket to the past. Quantum uncertainty doesn't mean events happen without cause. It means we can only predict probabilities. Entanglement doesn't let you send messages backward in time. It doesn't even let you send messages faster than light. And every serious attempt to combine quantum mechanics with time travel runs into the same brick wall. Contradictions multiply faster than explanations. Quantum mechanics is subtle, but it is not sloppy. Let's suppose, just for fun, that you could go back. What exactly would you fix? Your biggest mistake? Which one? And according to which version of you? You only know what to change because of what happened after. Remove the consequence, and you remove the lesson that motivated the change. The idea of correcting the past assumes the past is wrong. Physics doesn't recognize wrong. It recognizes what happened. The universe does not optimize for happiness. It optimizes for consistency. Here's a statement that sounds trivial, but isn't. All physics happens now. Not because now is special, but because observation, interaction, and measurement all occur locally. You don't live in yesterday. You don't live in tomorrow. You live where interactions occur. That's why no one has ever experienced time travel firsthand. Not because it's forbidden by imagination, but because experience itself is anchored to local processes. You can predict, you can remember, but you can only act here. People look for spectacular miracles, time machines, wormholes, cosmic shortcuts. They overlook the obvious miracle, that the universe has order at all, that equations work, that clocks mostly agree. That causes reliably precede effects. Without that, there would be no memory, no learning, no science. Time's rigidity is not a flaw. It's the reason anything coherent exists. Physics is often accused of killing wonder. That's backwards. Physics kills false wonder, the kind built on vague words and comforting illusions. What remains is deeper, more precise, harder to swallow, but infinitely richer. Time travel fantasies are attractive because they promise escape. Physics offers something better, understanding. And understanding doesn't let you escape reality. It lets you face it clearly. Time does not owe us reversibility. It owes us consistency. And so far, it delivers. You are not trapped by time. You are defined by it. Your thoughts, your growth, your discoveries all require sequence, irreversibility, and memory. A universe where you could freely jump around in time would be a universe where meaning dissolves. So where does that leave us? Time travel to the future? Yes, in a limited, measurable sense. Time travel to the past? No evidence, no mechanism, no experiment. And that's okay.